Hi, I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 12th. Tonight we'll be discussing jet stream roller winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see a pretty placid pattern. Small area 20-foot seas pushing under New Zealand, but other than that, things are pretty quiet. As usual, we'll start off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, sort of like this, a little push in the jet up to the north. And then what that helps do is create a clockwise flow aloft. That is the hallmark of low pressure. It also does it down at the surface. If it's strong enough, that generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a little trough southeast of New Zealand, and it's only the southern branch of the jet right there, not the northern one that we're so interested about. It's right here, and the problem is winds are very weak in the southern branch, and that has been the case pretty much all summer. I mean, one little pocket of 100-knot winds, just barely. I mean, you really need at least 120, 130-knot winds to get a decent fetch to evolve out of it. So right now, basically, no real support for gale development is indicated in the southern branch of the jet. As we go into Monday night and Tuesday, I mean, still a pretty good trough is set up here. There's just not enough wind energy pushing up into it. And then as we get into Wednesday, the trough gets cut off. You see the jet pushing south, and that was the trough. That just robs it of any energy and provides no support for gale development. Now, as we get into Thursday, it looks like another trough is forecast developing, but the ice line's like 62 south, somewhere right along there, and the jet has to get pretty well north of that ice line. And given the time of year, I mean, this is pretty normal for the ice line to be very far north because it's the dead of winter down the southern hemisphere. So, looking at that, no real hope. And then we get into Friday, and we get the opposite of trough, a ridge. The jet, yeah, pretty strong. What is that, 130-knot winds, maybe even a little bit more, but pushing southeast, not northeast. That's what we want. And right over the ice line, offering nothing other than maybe making some sort of a storm over the Ross ice shelf or something like that. Now, the jet actually looks pretty solid right there as we get into, we're 180 hours out. Yeah, but just no trough. So at least from the upper level, it looks like there's no support for gale development. Let's go take a look down at the surface. So here we are, surface level pressure, surface level winds. We're looking, there is low pressure. We know there's a trough there, but it's weak, right? 30-knot winds. You need more wind energy in the jet stream pushing northeast into that trough to help really get this low pressure ramped up. And based on what we saw in the previous charts, that isn't going to happen. And here we go. We're looking at the surface charts, and no, it's not happening. I mean, you need for the southern hemi to generate swell to radiate, you need about at least a 16-second period to make it the whole way up in the northern hemisphere without significant decay. So at least 40-knot winds over a pretty good-sized area. That would be this sort of a tannish, reddish type color. There's 35-knot. There's 35, maybe a little bit more, but just nothing. Oh, there we go. 40-knot winds, and just barely north of the ice line on Wednesday night into Thursday, but over a very small area, and then fading. Probably not enough. Then here's another broad area 35-knot winds, but they're all aimed southeast, and this is on Friday night into Saturday, and just nothing. Now there's a gale, 40-knot winds, but it's right on the hairy edge of the ice line and aimed, well, there's 45-knot winds, but it's over Antarctic ice. Kind of hard to generate swell when the wind's blowing effectively over land, and that's it. So far, no hope in the upper levels, no hope in the lower levels. Let's go take a look at the wave model, see if it tells us anything. Now we're going to go back in time just a little bit. This was Friday, a couple of days ago. There was a tiny little gale that passed under New Zealand Friday morning, generating, what was that, 1 pixel of 30-foot seas? That's not much. Building to about 34 foot. Here's the max significant wave height over this entire domain here. 34.9 feet at 57.5 south. Well, there's 50 south, 60 south. So, yep, right there. And 167.5 east. Yep, there's 60 east, 170 east, so right about there. Yep, that's good. 34.9 feet, okay, for, 6 hours or something. And then 35 feet, and actually falling southeast. The odds of there being any decent swell radiating from that are pretty small. Hawaii might get a little pulse. We're talking maybe 1.25 feet or something, maybe 1.5 feet if you're lucky. California, we'll see about that. Give it a day or two. Anyway, and that is the end of that. Now let's go to the forecast. So here we are today, and we don't expect to see anything based on the jet stream charts, based on the surface level charts, and what makes waves? Wind on the ocean surface. So if you're looking at the surface charts and you don't see anything, oh, there we go. A little area of 27-foot seas, maybe some tiny little swell. Maybe it'll register on the buoys in California and Hawaii, but not really be rideable. And then broad areas of 20-foot or so seas. We'll see. I mean, if the low could nudge a little bit further to the north. There's your ice line, by the way. 63 south, 62 south. Something like that. The problem is it's just pretty much hot. Whoops, there we go. And we're at the end of the chart already. So basically, nothing clearly obvious. No 30-foot seas or greater forecast for the southern hemisphere for an entire week. And last week we only had one little area that we saw there, 35-foot seas for a day or so, a day and a half. So at least maybe there's some little tiny swell coming. But other than that, things pretty quiet. Let's go take a look for wind swell. And wind swell has been sort of the saving grace when there isn't southern hemi swell. So what do we have? High pressure, 1030 millibar high here. We'll call northeast of Hawaii. Was that 20? And that's at 40, so about 1,200 nautical miles. Winds flow clockwise around high pressure. So that's as the high pushes up against California, it generates a little bit of a pressure gradient with heat low inland. Tightens up the isobars, generates wind. 20-knot winds. There's some little wind swell in California right now. What was it, waist high today? Maybe a couple of chest high peaks. Pretty formless, pretty insignificant, and that was only at the most exposed breaks north of Point Conception. Also, trades trying to push into Hawaii, most of it's east of Hawaii. The remnants of Christina, which was a tropical storm, probably not even enough to generate any swell for California. As we get into Monday, winds pick up, high pressure pushing closer, 25, almost 30-knot north winds for Northern California. That's certainly good for wind swell. East trades for the Hawaiian Islands, north of the islands, 15 knots or so. Probably some wind swell at exposed breaks there. We get into Tuesday, same drill, 30-knot north winds for Northern California. That should generate some wind swell there. Trades continuing over the Hawaiian Islands, not particularly strong, not over a particularly large fetch area, but probably enough to generate something. Wednesday, variation on the same thing. And then Thursday, more of the same. Fetch actually builds. Notice the slow pressure here. The heat low that's inland sets up over the coast. That'll generate an eddy flow, south winds. Wind flow counterclockwise in the northern hemisphere. So you get that south wind flow. Might also be a signal of some heat. We'll see. We get into Friday. More north winds and wind swell for California, more eddy flow, trades for the Hawaiian Islands. Pretty steady. It's almost like a machine. The high is just locked in place. Saturday, more of the same deal. If anything, the fetch builds off California or along California. And then Sunday, it's almost taking a northeasterly tack away from the coast. Maybe lesser wind swell, though the fetch area itself looks larger. And then we're into, Sunday night, almost into Monday. Looks like almost fading wind swell after next weekend. So, right now, best hope, looks like steady diet of wind swell at exposed breaks. And other than that, not a whole lot. Snow forecast. Why are we looking at snow forecast? Well, clearly, there's no snow. This is for the dashboard for Squaw Valley. But what's interesting, this is what we look at to see where the freezing levels are. At Squaw, this is the base of the resort. This is the highest peak at the resort. And red over here, liquid precipitation above 34.6 degrees. I mean, you can actually get snow flurries at about 34, 35 degrees, depending on what's going on in the upper atmosphere down at the surface. But the point being here, at 14,000 feet, it's above freezing. No big deal. I mean, that's not expected. But if you're backpacking or something in the high Sierra, you go, well, do I need to be worried about, really cold temperatures at night? It certainly doesn't look like it at all. And winds, we'll just take a quick look. Calm winds, 20 knots or less. That's gusts, so nothing going on there. Let's go take a look long term. What's going on with the MJO, the Madden-Julian Oscillation? A periodic weather oscillation travels west to east across the Pacific on the equator. And when in the active phase, that helps feed energy in the jet stream, helps support storm development. And when in the inactive phase, tends to dampen storm development. And then what's going on with El Nino or La Nina? We're on the cusp. We'll find out. All right, so let's go take a look. We're looking for the active phase of the MJO. We're actually looking for signals or signs of the active phase of the MJO. First thing we look at is surface level winds across the Equatorial Pacific. This is the equator. East Pacific here, West Pacific here. That's New Guinea. International dateline right there. And this is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but they do pretty good at helping to monitor the MJO as well. We're just looking at the arrows. The arrows indicate east winds. This is 5-day average winds, so it's not real time or anything like that, but it gives you a good sense of what's going on. Strong east trades, big arrows, strong east trades over the East Pacific, Central Pacific, and over what we call the Kelvin wave generation area, the far West Pacific. This is where, when the active phase moves over here, if it's strong enough, it can reverse or at least dampen trade winds, allowing warm water that's typically here to start sloshing east. If you get successive active phases of the MJO, and they are strong enough, and trades reverse or dampen as they normally do, then you get a Kelvin wave, a ball of warm water here that moves under the equator, 150 meters below the ocean surface, all the way across the Pacific. 3 months later, erupts off of Ecuador, forms a slick of warm water. If you get successive active phases of the MJO, then that can help form El Nino, which is characterized by warm water buildup off of Peru and Ecuador. Now, the flip side is also true. When you have strong easterly trades, no active phases of the MJO, you get a lot of upwelling over here. All the warm water balls up in the West Pacific. You get no active phases of the MJO. Kelvin wave activity ceases. You get massive upwelling and cool water here. That helps set up high pressure over the eastern Pacific, both north and south. Kind of just stomps on the jet stream and tends to make storm formation not particularly prolific, and when you do get storms, they tend to be weaker than usual, shorter lasting than usual, and not great at shorter duration, not great at producing swell production. And so, anyway, so we look at anomalies, differences from normal for this time of year. We're looking for westerly anomalies anywhere, but preferably in the Kelvin wave generation area. Well, we see arrows from the east, so that means the trades are blowing harder than normal in the East Pacific. Kind of neutral, and we're just 5 degrees north and south of the equator. That's all we care about. Central Pacific, pretty much normal. Stronger than normal in the the West Pacific, out of the east. That looks like the inactive phase of the MJO. All right, that's not good news. Let's continue on looking for more signs. One bit of data doesn't tell you a trend. You need to confirm it. So let's go look for other signals. 850 millibar wind anomalies, okay? That east-west component of the wind thing. The blues are easterly anomalies. The oranges and yellows, westerly anomalies. What are we looking at here? South America, Central America right there, Australia there, New Guinea there, Philippines there, equator, 0 degrees right there. And the West Pacific Kelvin wave generation area right there. Blues, easterly anomalies. That's a sign of the inactive phase of the MJO, and that was on July 6th, 7th, Same thing on the 8th. If anything, building on the 9th, building on the 10th. East anomalies filling the Kelvin wave generation area. That's not helpful either. So let's go look at a forecast. Hopefully things will change. All right, so outgoing long wave radiation, most of you understand this now. This is the amount of sunlight reflectivity off the ocean surface. If you're in the active phase of the MJO, the one that we want, it's like low pressure, and it produces rain and clouds, and so you get this blue, negative anomalies, more clouds than normal. When you see the oranges and yellows, that means more sunlight, high pressure, inactive phase of the MJO. So where's our Kelvin wave generation area? Right there in the West Pacific. There's Australia, New Guinea, Equator. It says EQ, Equator. Okay. So that pretty much says inactive phase of the MJO today, but fading quickly. This per the statistic model 5 days out. Very weak, and it may be a very weak active phase showing up 2 weeks from now. Okay. The dynamic model, as you can see clearly, is corrupted. Something's going on. They just need to go work on the website. But so we can't look at that. It doesn't give us any indication of what's going on. But fortunately, phase diagram charts are working good. All right, so what are we looking at here? Assume you're looking down on the North Pole. We're looking for the position of the active phase of the MJO and where and how strong it is. All right, so we're looking down on the North Pole. The MJO travels from west to east on the equator, out around the edges here, from the Indian Ocean over the Maritime Continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. It just goes round and round and round the planet. It takes a while to do that, like, I don't know, month and a half, something like that. Anyway, the heavy dot is where the active phase is right now. So in the far western Indian Ocean, the further the dot is away from the circle, the stronger it is. So say a pretty weak active phase of the MJO. And this is the forecast projection, meaning 3 different tracks per the statistic model here. It is expected to make it to the Maritime Continent, maybe towards the West Pacific 2 weeks from now, and very weak. The dynamic model saying basically the same thing, somewhere Maritime Continent, and so weak as to almost not even be present. So that is not particularly encouraging either. Okay, here's a 40-day upper level model. Areas favorable for precipitation are indicated in green. Areas not favorable for precipitation, orange and yellow. So that can be indicated to be, this would be the inactive phase of the MJO. This would be the active phase of the MJO. Now, this chart runs about a week ahead of what actually goes on the surface. So right now, inactive phase of the MJO. Oh, sorry. There's the equator, 0. Right? South America, Central America, Australia, New Guinea. You get it. Kelvin wave generation area right there. So inactive phase of the MJO, exiting the Pacific and over Central America. The end of July, let's say. Now to the picture. Inactive phase supposedly starts building, moving into the Pacific. We'll say about the end of July. And the whole month of July, it starts making its way, the whole month of August, it starts making its way across the Pacific, though pretty weak. You can see strong inactive phase, kind of muddled active phase, another building inactive phase behind that. Sweet spot right now looks like August. This really isn't that unusual. Typically, July, things get pretty quiet. We just had a bomber southern hemi swell in California and Hawaii. So it's time for a bit of a break. Seasonally, this is normal, though the thing that's disturbing here is the strength of the inactive phase and the relative weakness of the active phase. And then next up, the, what is this? Cfs Model. 1 month forecast. All right, so what are we looking at? Whole planet on one chart. The international dateline, 180 west, right down the middle. So the Kelvin West Pacific starts at about 135 east, right there, and goes to about 80 west, right there. That would be like Ecuador, and this is just on the equator. All right, so what are we looking at? The blues are easterly anomalies. The reds, yellows are westerly anomalies. So if the Kelvin wave generation area in the West Pacific starts here, and California is here, and Ecuador is somewhere over here, you see the prevalence, the consistent east anomaly pattern taking shape, and if anything, building, filling the entire Pacific for the next month. Also with this purple dashed line, that is the low pass filter that suggests a high pressure bias building in the Pacific over the Kelvin wave generation area that is synonymous with La Nina most of the times. We see the active phase, so this is the inactive phase of the MJO here, but it doesn't even really make it to the Pacific. Inactive phase, it's over the Indian Ocean. That seems to be where all the focus of activity is in the Pacific, just going to sleep. And then finally, the 3-month CFS model. So past performance is down here. The forecast is here. The thing that grabs your eye is, oh, look at that. These solid red contours. That's a big active phase of the MJO forecast at some point. So we'll get into that in a minute. But here we are today. Kelvin wave generation area. West Pacific starts right there, 135 east, and goes to Kelvin wave generation area ends right there. So we're just going right up through that part of the picture. The blues again, easterly anomalies, dotted contour, inactive phase of the MJO, inactive phase forecast over the Pacific the whole way to Ecuador through August something, mid-August or so. And then even when the active phase, and a pretty strong one, sets up, strong easterly anomalies are to prevail, filling the Pacific Ocean. Yeah, you got a little hint of westerly anomalies. And then after that, when you get into late September, early October, more of the same. This definitely smells like La Nina. So let's overlay the low-pass filter. That'll make things a little bit clearer what's going on. And here we go. So this dotted contour, we've been watching this. High-pressure bias, in control already, with a second contour forecast by first week in August, and a third contour by September 14th. As you're getting into fall, all this suggests is high pressure taking over the Pacific, typical La Nina pattern, and then the low pressure bias is in the Indian Ocean, favoring storm development there. Now notice, earlier this year, this was the tail end of like a 2 or 3 year pattern. The low pressure bias was in the Pacific, the high pressure bias in the Indian Ocean, and now, boom, they're reversed. It certainly smells, at least according to this model, and it has been consistently suggesting La Nina development. Now here's where things get a little bit confusing. Now we've talked about, the MJO part of it. That's sort of an atmospheric component. Let's go look in the ocean. The ocean plays a part in El Nino, La Nina as well. This is the West Pacific here. This is the East Pacific. We're looking at temperature profile in the ocean under the equator the whole way across the Pacific. These are the anchor lines on the TA buoys. The X's are sensors. You take the data from the sensors, run it through a model, fill in the gaps, you get a profile. We see warm water. What is this? The 29 degree isotherm. No 30 degree centigrade isotherm, just the 29 degree isotherm. But it was like, it's at 170. That's about where it's been, something like that. 28 degree isotherm, actually pushing east a little. It was 160, 155. The 24 degree isotherm was last like in the spring, early spring, pushing into Ecuador. It's backed off some, pushing a little bit east for the moment to 115 west. Okay, so what's this all mean? Well, let's look at anomalies. The difference in normal for this time of the year. And what do we see? Well, we actually have a sort of a better picture developing. We see warm anomalies, only 1 degree above normal, not down at 150 meters deep where you'd expect to see them from a Kelvin wave. What you see is above that, pushing east to about, about 110 west. So south of California, maybe Mexico, Baja, something like that. And this is looking better because we had a huge pocket of very cold water here a couple of weeks ago. And it seems to have all gurgled up to the surface. But there's this new pocket of cool water setting up 1 degree below normal at 150 meters down, exactly where you'd want to see warm water pushing off to the east. This looks like the inverse of a Kelvin wave, or a cold water Kelvin wave, if you will. We'll see if that continues to push east and build. We suspect it probably will, especially with the models suggesting strong easterly anomalies building over the whole Pacific over the next couple of weeks. All right, another view, there we go, from a different model, same raw data, basically saying that it shows the cool waters here are a little bit more pronounced. This thing seems to run about maybe a week behind, something like that. But then here is this newly developed 1, 2, 3 pockets of cold water. And they look like they're following the typical pattern that a Kelvin wave would follow. So, yeah, there's warm water around, but it doesn't look like it's going to last for long. It's more like there's a pause right now in the activity, and we're thinking as east anomalies get set up in the Pacific, these guys are going to start blooming, pushing east, and the cold water regime is going to start building again. Sea level anomalies. Okay, this isn't temperature. This is the height of the ocean. If you have cold water depth, it contracts, makes a little divot on the ocean surface. You have warm water. We're just talking 2 degrees temperature difference. It expands. It'll create a bump on the surface, so you can get a sort of an idea of what's going on temperature-wise subsurface. We see cool anomalies along Peru and Chile and Central America, but not as cold as they were. And I'm sorry, not cold. Height. Negative anomalies, but that suggests cold water. Not as deep as it was, not as pronounced as it was. We think that will probably build in the future. And then just sort of a normal pattern over the bulk of the Pacific. But any positive anomalies suggesting warmer water, all isolated to the far west Pacific. And you sort of get the sense that there's like a current slamming into this and carving the warm pool out into like a horseshoe pattern here. So that suggests an easterly trade wind pattern. No sign of any Kelvin waves, no sign of any active phase of the MJO, anything like that. Upper ocean heat anomalies. All right, so this is the West Pacific here. This is the East Pacific here. Dateline is roughly right there. All right, so last summer, we had the same deal. We got cold water building up in the East Pacific. It almost looked like La Nina, but it wasn't. And then magically in September, we got this Kelvin wave, warm water, these oranges, yellows, from a active phase of the MJO that created westerly anomalies that pushed warm water the whole way across the Pacific. Then we got another 1, 2 kind of weak Kelvin waves. They never really made it hardly to Ecuador. And that was, you sort of got the sense that it was the fading last gasp of the Kelvin wave generation area machine kind of just going into hibernation. Lack of heat in the Pacific, lack of energy, some sort of a pattern change. And here we are in April, cold anomalies, cold temperatures started developing. Same kind of deal like last summer. And it looks, for the moment, you see right now, June, July, warm water slowly making barely warm water making its way off to the east. The question is, will this actually sort of take over and hold, or will cold water start building again? With the models suggesting strong easterly anomalies, not only building over the Kelvin wave generation area, but the whole of the Pacific and lasting for months and months, it seems like at this point in time, this cool pocket's going to regenerate and maybe even be stronger than what it was this spring. We'll see. All right, surface level temperatures. These 4 pictures are sort of a zoomed in view. That stream of cold water there pushing off of South America is the same as this one. They're just not all lined up just right. But you get the sense, cool water along Peru. Ecuador is right there, streaming off Ecuador. But and streaming on the equator out to, 160 west? So there's Hawaii, south of Hawaii. So this looks like a weak start of La Nina. It was actually stronger a couple of weeks ago, but it's been fading lately, as you've seen on some of the charts. The question is, again, unknown, but if easterly anomalies start building, will this start the upwelling machine again, and will this cool tongue start building? Here's the trend, sea surface temperature trend, just for the past 7 days. Where the blues are, temperatures are cooling, suggesting some upwelling going on, and it's really just on the equator we're interested in here. There's Ecuador, some upwelling. It's actually a little bit less strong than it was 2 days ago, 4 days ago kind of thing. And then warming, not really, sort of like near the date line, but nothing. If anything, and generalized cooling off of Peru. And again, it's only 5 degrees north and south of the equator over the equator over the whole of the Pacific that really matters. What's going on up here or down here, not so much. And then the backed off view. Here we go. Again, cool water, almost, in the part that matters. The official El Nino monitoring region is this area 120 west to 170 west, 5 degrees north and south of the equator. If you look at that, you go, yeah, there's some cool water there. There's some warm water there. Almost looks, about a 50-50 split. But you see all that cool water off of South America, over the Galapagos. That plays a part too. I mean, wherever the cool water is, that's where the leading edge of high pressure is. And that sort of suggests to us a dry winter setting up if this pattern continues for California, and also suggests high pressure north of wherever the cool water is, which also means storm development in the Gulf of Alaska, pretty low. Whatever happens is going to be over in the far west Pacific. High and dry. Maybe you get one of those continuous offshore sort of winter things going on in California, which is nice for conditions. Small surf, maybe longer period surf, but no big raging kind of storms, no big blasts of powder into California. It all would get shunted to the north. In fact, here's another view. So what would happen is if you had high pressure in this area, the jet stream would go north up into, we'll say, Washington, Oregon. And it's entirely possible that all the water would end up there. During La Niñas, you get flooding, massive snowstorms up in British Columbia, Washington, that area, and then falling down into the central United States, where the Southwest, bone dry. So that's kind of looks like where we're going. See surface temperature trend in the Nino 1.2 region. That's the area right there by the Galapagos and Ecuador. The temperature today, minus 1.829 degrees below normal. That's pretty cold. That's way below normal. You see the trend. It was half a degree above normal for 5 consecutive months. Now, this isn't the official El Nino monitoring region, but just for comparison, we were trying to be there like last winter, but we're nowhere near that in the Nino 1.2 region. Now, in the Nino 3.4 region, the official El Nino monitoring region, we were down in La Nina territory. That's 0.6 degrees below normal. But we've rebounded for the moment because the easterly trades in the East Equatorial Pacific have backed off. The question is, will they start nuking again? Will temperatures start falling again? Will that push us into La Nina? We don't know right now. So we go looking for more signs. What's going on in the atmosphere? Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. When the index is negative, that means there's lower pressure over Tahiti. That means lower pressure over the Equatorial Pacific. That typically means El Nino, or at least the active phase of the MJO. Today's value, plus 16.74. One day does not a trend make, but you go back and you look, and it's been positive a lot, other than a little spurt in here where a tropical system was pushing directly over Tahiti. All right, 30-day average takes some of the noise out of there. The value today, minus 2.20. Go, hey, that's below normal, not much. And you see we were down at minus 7, something like that. But a month ago, we were at minus 2.12. So we're still, according to this, the 30-day average is sort of like your active phase, inactive phase of the MJO index. Just saying, we're neutral. Okay, that's not horrible. 90-day average, that's your El Nino indicator. Minus 1.26, that's bone neutral, dead neutral. We're down at minus 2.36. So it's not like radically moving towards La Nina, okay? But the ocean certainly looks like La Nina. And if anything, though, with that cool pool sort of backing off, maybe not. We'll see. But here's the flip side. The Cfs model has just been consistently saying massive easterly anomalies taking over all the Equatorial Pacific. And that is, like, in the next week or two, that's our do or die time. We'll see whether the CFS really has some magic sense of what's going on or whether it's completely out to lunch. Now, one other oscillation, Pacific Decadal Oscillation, right? This is not a Like the MJO is in the Pacific, it's 3 weeks active, 3 weeks inactive, maybe 3 or 4 weeks, something like that. Overlaid on top of that cycle is the is the El Nino La Nina cycle, which is like an El Nino every 7 years and sort of La Nina for a year or two, somewhere scattered in there. And then there's this theoretical oscillation, which is like every 15, 20, or 30 years. And you can see the blues here are the negatives. That's the La Nina phase. And just eyeballing this, you get a sense somewhere in like mid-1940s, we started going cold negative. That would be like the cool phase of the Pacific decadal oscillation. Then in like the late 70s, we started warming up. We went through a very warm period. And then in like the El Nino of 98, that was the peak. It died. We went back into a La Nina phase. We were thinking with the El Nino of 2014-15 that we were heading back into a warm phase. Here's where we are today. Hard to tell what's going on exactly. These sort of trends, you're not going to know whether you're really in the warm phase till you're 10 years into it or so. And right now it's sort of almost a split bag. We had, maybe 3 or 4 years of warmth, and now 3 years of, I'll say, not warmth, cool. So hard to tell what's going on exactly, though theoretically we should be in the warm phase of the PDL. And then finally, the sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. Where are we today? We're in July, mid-July. The model suggesting temperatures should be heading downward. They're actually not. We saw them. They're heading up at the moment, though this model has been extremely good at what it does. The forecast, temperatures crashing at some point in July, heading down the whole way through the rest of the summer into the fall, down to minus 1.15 degrees. That would be deep in La Nina territory in the December time frame, bottoming out, and then theoretically warming after that. So this model is a bit of an outlier. NOAA, though, this model has been saying this for months, and it was spot on when every other model didn't get what was going on. And sure enough, temperatures crashed in the, April, May, June timeframe. This model saw it months ahead of anything else. This model's been consistently saying moving to a La Nina pattern this fall and winter. Right now, the ocean's kind of looking like it's trying to rebound, but this is the same model that's saying massive easterly anomalies are forecast for the coming months, starting like any day now. So the trick is the model right, or is something else going to happen? We don't know. The model, it's a bit of a reach. It's hard to look at a model and believe it even a week out, much less months out, though the model is doing pretty well. NOAA officially has come out, though, and saying, hey, we're in a La Nina watch now. It's possible we could move to La Nina. There's a couple other models that are sort of on board with this idea, too. Though, you see the cold water setting up and fading as of late, and you go, well, is this really going to happen? I think we're going to find out. Let's give it the next 2 to 3 weeks. We'll be watching pretty close. We'll be doing these videos, and that's what our focus is going to be. Are the easterly anomalies going to build as strong as their forecast, and will that cause upwelling, and will that cause ocean temperatures to start crashing? Because if they do, even by the time you're into early August, which is 2 weeks away, 2.5 weeks away, something like that, then that sort of sets the tone. Maybe we're in the doldrums here, and as soon as you get into fall, the MJO sort of wakens up, and it sort of really gets its groove going. That said, I think this is a bit overstated. I think we're going to be in La Nina, but not down at minus 1.1 degrees, maybe 3/4 of a degree or something like that. A weak to modest La Nina type thing. But that's just a guess based on what we know about this model and how everything's been going to date. All right, so for right now, well, we had our surf. Southern hemiswell, at least in California, was pretty much solid last weekend. No doubt. It was bombing. You've read about it. You've seen it on social media and all that sort of thing. Now we're paying the price. Pretty quiet. Wind swell seems to be the name of the game. Yeah, there's a potential tiny little southern hemiswell coming, but nothing to get too excited about. Wind swell's the name of the game. You just got to kind of suck it up, make the most of it. You know, we've had pretty good run of surf for quite a while now. Nothing epic other than last weekend, but, you know, waves are waves. It's summer. The doldrums of summer, they're here. So make the most of it, and we'll see what happens. Right now, officially, we're supposed to be moving to La Nina. The question is, how strong? How long will it last? And will it actually materialize? It's a pure projection based on the models. It's a figment in the imagination of some computer somewhere. And you know how that goes. How much do you want to bet money on that? But suspect it's probably going to happen in some fashion, one way or another. All right, so that's it for this week. If you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, hit the subscribe button. You get automatic notifications every time we post a video. Also, if you don't want to do that, that's okay too. Go to stormsurf.com. We put links to the videos when we post them, and they're typically Sunday evenings, about the same old time. So you know the drill. And other than that, be safe, be smart, don't get yourself sick. Go surf, go have some fun, enjoy life, and we'll see you next week. Same time, same channel. Thanks for watching.